the sign convention in lenses continued, and the lens formula. As we talked about in the last section, we have a very similar convention for lenses as we have for mirrors. The conventions are identical except that in the case of the lens, we are using the geometrical center of the lens as the reference point. This brings us to the lens formula, which is 1 upon V minus 1 upon U is equal to 1 upon F. So you may notice that this formula is very similar to the formula we use for mirrors except for the switch sign. Here it is negative 1 upon U. You may wonder why this is the case. Think about it. In the case of a mirror, the image is being caused by the bouncing back of light along the same path that it came from. Whereas in the case of a lens, the light is proceeding in the same direction as it was earlier. It is slightly bent to the side. Because of the fact that in a lens, the light never reverses its direction, we have this difference in the formula. Next, we have the magnification formula, which is given as the ratio of the image size to the actual object size, or h dash by h. Numerically, this is equal to V upon U. Next, we have the power of a lens. The power of a lens is the amount by which a lens can converge or diverge a given beam of light. It is the inverse of the focal length and is measured in diopters. The symbol is capital D. Larger, flatter lenses tend to have smaller power than smaller, rounder lenses, and vice versa. Applications of lenses. Just as with mirrors, whenever we wonder what is the application of a given lens, we should ask ourselves this question. Am I trying to get a magnified image of the object under study or a diminished image? Or whether I am trying to spread the light out into a wide region or get a clear, condensed and focused beam of light at a point. By looking at these considerations, we can see that for magnifying an image, we can use convex lenses. On the other hand, if I am trying to extend the focal length of a given lens combination, I can add a concave lens in that case. Many advanced optical systems, like lenses used in cameras, telescopes, use a combination of both convex and concave lenses to get the desired effects.